To predict the relative strength of dispersion forces between molecules, you have to understand what dispersion forces actually are. So remember, dispersion forces are present in all atoms, molecules, etc. They come from temporary or instantaneous dipoles caused by random motion of electrons, okay? So at any given instant, you could take a snapshot of where all your electrons are, if only, I wish, right? And they may be unevenly distributed throughout your molecule, okay? In which case you're going to have a temporary dipole just for that split second, okay? Where all the electrons are is going to be an area that's slightly more negative, and this is going to have an effect on neighboring molecules. And this is the dispersion force. So what causes a greater or a smaller dispersion force is going to be directly proportionate to the number of electrons. The more electrons there are in your molecule, the greater the magnitude of dispersion forces. Dispersion forces are also affected by the shape of your molecule. So like long chain type molecules tend to have greater dispersion forces than more compact spherical type shaped molecules. Why? Because that temporary instantaneous difference in distribution of electrons is going to be exacerbated by a longer chain shape. If they're all down one end of the molecule compared to the other, then you're going to get a greater degree of instantaneous dipole. So what causes a higher or lower boiling point is going to be directly proportionate to any kind of intermolecular forces, okay? Because intermolecular forces are what are holding the molecules closer together in the liquid state. So when something boils, it's overcoming those intermolecular forces holding the liquid molecules closer to each other until those particles have enough kinetic energy to escape into the gaseous phase where they have greater freedom of movement because they have overcome the intermolecular attractions between molecules. So the quick and easy way to look at these kind of questions is to look for what has higher molar mass, because molar mass is going to be proportionate to number of electrons, okay? So remember, in any atom, the number of protons, right, the atomic number Z is going to be equal to the number of electrons. So comparing dihydrogen with dibromine, bromine has a much higher molar mass than hydrogen, right? I think it's 79, something like that, right? So it's going to have a much higher boiling point. No, 35. 79 would be the molar mass, right? That's got the neutrons in there as well. So either way, bromine's got more electrons than hydrogen. Germanium hydride versus germanium bromide. Again, hydrogen versus bromine. Bromine has got more electrons per atom than hydrogen does. So it's going to have a higher degree of dispersion forces because the magnitude of them is going to be greater due to more electrons. So that's going to have the higher boiling point. Out of these two species, you can see there's a different number of carbons and hydrogens. So more carbons, more hydrogens, more electrons, higher magnitude of dispersion forces, more energy is required to overcome those dispersion forces. So that's going to require a higher boiling point. Okay, so hopefully that is helpful.